For millions of years, quartz has quietly protected one of Earth's greatest treasures. It sealed ancient fractures. It locked away boiling mineral-rich fluids. It preserved the moment gold finally became solid. But the remarkable truth is this. Quartz was never the beginning of the story. It was only one chapter. Long before a single crystal of quartz ever formed. Long before mountains rose above the clouds. Long before rivers carved valleys through solid rock. The journey of gold had already begun. Not inside a mountain, not inside a fault, not even inside the Earth's crust. It began far below the landscape we recognize today, a place no human has ever visited, a place where rock no longer behaves like the stone beneath your feet. Imagine descending mile after mile beneath a familiar American mountain. The forests disappear, the streams vanish, the bedrock grows hotter. Pressure quietly increases until every square inch of rock supports forces almost impossible to imagine. The deeper you travel, the stranger the earth becomes. Solid granite slowly loses its rigid character. Minerals begin rearranging themselves. Rock bends instead of breaking. The crust behaves less like stone and more like something alive. Everything above appears peaceful. Birds cross the sky, rivers quietly flow, trees sway in the wind. Yet beneath that peaceful landscape, the planet never stops moving. It breathes, not in seconds, not in years, but across millions of years. Continents slowly drift, ancient oceans disappear, entire mountain ranges rise before slowly wearing away again. Everything above changes because everything below refuses to remain still and hidden inside that enormous moving engine. Nature begins preparing one of its rarest materials. Not by creating gold. Gold already exists. The remarkable challenge is moving it. Gold is one of the most stubborn elements in nature. It refuses to travel. It refuses to dissolve under ordinary conditions. It refuses to separate from surrounding rock. If the earth behaved normally, almost every atom of gold would remain permanently trapped far beneath our feet, never forming deposits, never becoming nuggets, never reaching rivers, never entering human history. So the planet requires another strategy. One almost invisible. One astonishingly elegant. Instead of moving the gold itself, the Earth creates a messenger. Superheated water. But this is nothing like the water filling rivers or lakes. Imagine water heated until temperatures climb beyond 300 degrees Celsius. Now imagine that water trapped beneath unimaginable pressure. Under those conditions, water becomes one of nature's most remarkable transport systems. It begins dissolving materials ordinary water could never carry. Silica, copper, sulfur, silver, tiny traces of gold. The impossible suddenly becomes possible. Gold begins traveling, not as nuggets, not as flakes, not even as microscopic particles. Individual atoms quietly ride inside these invisible underground currents. Imagine following only one of those atoms, one tiny atom of gold, so small that billions of them could disappear inside a single grain of sand. For perhaps hundreds of millions of years, it remains imprisoned inside ancient rock, completely motionless, completely forgotten. Then everything changes. A distant tectonic collision slowly compresses the crust. Pressure increases. Old fractures reopen. Fresh cracks begin forming. Far below the surface, one underground pathway suddenly connects with another. The superheated fluid discovers a new route. Without warning, our tiny gold atom begins moving for the first time in its geological life. Not quickly, perhaps only a few centimeters each year, yet year after year, century after century, million after million years. The journey continues. No sunlight reaches these depths. No sound exists. Only darkness, pressure, heat, and slow movement. Imagine watching that invisible current winding upward through the crust. Sometimes the pathway closes. The atom waits. Another fracture opens nearby. The journey resumes. Sometimes earthquakes violently shake the surrounding rock. New openings appear. Old ones collapse. The route changes again. The gold atom patiently follows wherever the earth allows. It has no destination, only opportunity. But another remarkable event is quietly approaching. The journey cannot continue forever. Because the deeper fluids rise, the colder the surrounding rock becomes. Pressure slowly begins decreasing. The chemistry changes. Everything inside the fluid becomes increasingly unstable. At first, nothing happens. The gold remains dissolved. The current continues flowing. Then, without warning, the balance changes. The fluid can no longer carry everything it once held. One by one, minerals begin abandoning the solution. Quartz starts growing along microscopic fractures, layer after layer, crystal after crystal. The underground plumbing system begins slowly sealing itself, but our tiny gold atom still refuses to stop. It continues traveling, searching, waiting, because gold requires something even more specific. A final change, a final collapse of pressure, a final adjustment in chemistry. Only then, after surviving an unimaginable journey through darkness, does the atom finally lose its freedom. It settles, not dramatically, not explosively, silently, attaching itself to the growing walls of a microscopic fracture. One atom becomes two, two become thousands, thousands become millions. Slowly, almost imperceptibly, nature begins building something extraordinary. Not a nugget, not yet. Only the smallest beginning of what may one day become visible gold. The remarkable part. The mountain above still doesn't exist. The forests don't exist. The rivers don't exist. Even the landscape where a future prospector will eventually stand has not yet been born. Gold is already waiting. Hundreds of millions of years before anyone could possibly discover it. And perhaps that is the first great secret of gold. People believe they search for treasure. In reality, they are searching for the final chapter of a story that began long before the modern world itself. And the Earth has only just begun writing it. For millions of years, nothing changes. The tiny cluster of gold remains locked inside its narrow fracture, buried beneath mountains that have not yet seen daylight. Above it, the Earth refuses to stay still. Entire continents continue moving. Ancient oceans disappear beneath the crust. New mountain ranges rise where flat plains once existed. Every collision pushes the buried gold a little closer to the surface. Not because the gold is moving, but because the earth around it never stops changing. Then another remarkable force quietly takes over. Erosion. Unlike earthquakes or volcanic eruptions, erosion works with extraordinary patience. Every raindrop removes a few microscopic grains of rock. Winter ice slips into tiny fractures and gently forces them wider. Summer heat expands the stone. Gravity pulls against weakened cliffs. What appears motionless to us is actually one of the greatest engineering projects on Earth. The mountain slowly begins disappearing, not in centuries, but over tens of millions of years. The rock above the hidden gold becomes thinner. The pressure eases. The ancient quartz vein that once formed deep underground is now approaching daylight for the first time. Eventually, the impossible happens. The vein reaches the surface. For the first time since it formed, sunlight touches the quartz that protected the gold for millions of years. But the journey is still not over. Quartz may be incredibly strong, yet even it cannot resist nature forever. Rain enters its fractures. Roots slowly force cracks apart. Season after season, pieces of quartz begin breaking away from the outcrop. Some remain on the hillside. Others tumble into narrow gullies. Many eventually reach mountain streams. And with every fragment that breaks apart, tiny pieces of gold begin gaining their freedom. Now another silent force takes control. Gravity. Quartz is carried downstream, colliding with other rocks until it becomes smaller and smaller. Gold behaves differently. Its exceptional density allows it to resist the current. While lighter sediment continues its journey, the gold slows down. It settles into bedrock cracks, behind stable boulders, inside natural pockets carved by flowing water. Without realizing it, the stream becomes nature's final sorting machine. It doesn't create gold, it simply reveals what the earth prepared long ago. This is why every gold nugget tells two stories. One began deep beneath the crust inside boiling mineral-rich fluids. The other began the moment erosion released it into the landscape. The nugget in a prospector's pan is only the final chapter of an extraordinary geological journey. Perhaps that is why experienced prospectors spend so much time studying the landscape before searching for gold. They know the river is only the messenger. The mountain is the author, the fault is the beginning, the quartz vein is the memory, and the nugget is the evidence that the earth completed its work millions of years before anyone arrived. Now imagine picking up that nugget for the very first time. It feels cold, heavy, surprisingly ordinary. Yet hidden inside that small piece of metal is a journey longer than the existence of humanity itself. It survived unimaginable pressure. It traveled through boiling fluids. It waited inside solid rock. It watched mountains rise. It endured the destruction of those same mountains. It survived rivers, storms, glaciers, and countless ages of erosion. Only then did it finally reach the surface, where one observant person recognized its value. And perhaps that changes the way we should look at gold forever. Gold isn't remarkable simply because it is rare. It is remarkable because every single piece carries the history of a restless planet. A history written over hundreds of millions of years. A history of pressure, movement, heat, patience, and time. The next time you hold a gold nugget in your hand, don't think only about its weight or its price. Think about the invisible journey that brought it there. Because long before it became a treasure, it was part of the Earth's deepest heartbeat. And somewhere, far beneath the mountains we know today, another tiny atom of gold has already begun that same incredible journey. Hidden in darkness, moving silently through the planet's ancient engine, waiting for a future mountain to rise, a future river to flow. And perhaps one day, waiting for someone curious enough to uncover the next chapter in nature's greatest story. For millions of years, quartz has quietly protected one of Earth's greatest treasures. It carried gold upward from unimaginable depths. It sealed it inside ancient fractures. It released it through weathering, and eventually, it scattered nuggets across mountains, valleys, deserts, and rivers where patient prospectors continue searching today. But here's something few people realize. Quartz wasn't carrying only gold. During those same geological events, while mountains cracked, while magma slowly cooled, while mineral-rich fluids surged upward through the Earth's crust, nature was creating something else. Something that doesn't glitter like gold. Something that many hikers unknowingly kick aside every year, yet in exceptional quality. A crystal no larger than the tip of your finger can quietly be worth more than a heavy gold nugget resting beside it. At first, that sounds impossible. Gold has fascinated civilizations for thousands of years. Empires have risen because of it. Wars have been fought over it. Fortunes have disappeared chasing it. So how could one ordinary-looking blue crystal ever compete? The answer begins where almost every valuable gemstone begins. Not inside jewelry stores, not inside museums, but deep beneath ordinary mountains, where pressure, heat, and time patiently work together, long before anyone ever discovers the result. Imagine hiking through an old mountain range somewhere in the western United States. The trail seems ordinary. Granite outcrops rise beside you. Loose boulders cover the hillside. Pine trees hide the distant ridges. Nothing about the landscape suggests extraordinary wealth. Most hikers continue walking. Experienced rockhounds begin slowing down, not because they see gemstones, because they recognize the rocks capable of hiding them, and perhaps the most important of those rocks appears surprisingly plain. From a distance, it looks like nothing more than pale granite. Walk closer. Something feels different. The crystals seem unusually large. Individual feldspar crystals are easily visible. Quartz appears in thick, glassy masses. Everything looks oversized, almost exaggerated. That rock has a name. Pegmatite. To most people, it is simply another outcrop. To experienced collectors, it is one of the most exciting rocks on Earth, because pegmatite doesn't simply contain minerals. It grows giants. But why? The answer takes us back beneath the mountain. Imagine a giant body of molten granite slowly cooling several miles underground. Most of the magma solidifies first. Quartz begins forming. Feldspar follows. dark minerals crystallize. Eventually, only a tiny amount of liquid remains. Yet that remaining liquid is unlike ordinary magma. It contains enormous amounts of water. Rare elements, volatile gases, beryllium, lithium, fluorine, cesium, elements that refuse to enter the earlier crystals. Instead, they became concentrated inside the very last drops of molten rock. Now something remarkable happens. Those final fluids force their way into nearby fractures. Unlike ordinary magma, they cool incredibly slowly. The crystals suddenly have something they almost never receive: space, time, freedom to grow. Instead of tiny crystals packed tightly together, gigantic crystals begin developing. Some eventually become larger than a human arm. Others grow into perfectly formed transparent columns, and hidden among them, nature quietly begins creating some of the world's most valuable blue gemstones. Now here's the first field technique. Most beginners search directly on top of pegmatite outcrops. Professionals often inspect the slope below. First, why? Because weathering has been attacking that pegmatite for millions of years. Rain enters tiny fractures, winter ice expands them, summer heat weakens them again. Little by little, individual crystals escape. Gravity does the rest. Instead of remaining inside the outcrop, loose crystals slowly migrate downhill, sometimes only a few feet, sometimes hundreds of yards. Long before you discover the original pegmatite body, nature may already have placed samples directly in your path. That simple observation has led experienced collectors back to remarkable crystal pockets. Another discovery begins appearing almost immediately. Not every pegmatite deserves your attention. Some contain nothing more than quartz and feldspar. Others quietly concentrate rare minerals that occur almost nowhere else. How can you tell the difference? Look at the crystal size. The coarser, the pegmatite. The longer the final fluids remained active. Long-lived pegmatites had more opportunity to concentrate rare elements, and those rare elements became the building blocks for extraordinary gemstones. Now another reward. Watch how the pegmatite behaves. Does it continue as one thick body through the mountain, or does it suddenly split into several thinner branches? Experienced geologists rarely ignore branching pegmatites. Those branches often represent multiple injections of mineral-rich melt entering the surrounding rock. Every new pulse changes the chemistry. Every change creates another opportunity for unusual crystals to develop. Nature isn't simply building rock, it's conducting one of the slowest chemical experiments on Earth. And eventually, one remarkable blue crystal begins appearing. Not sapphire, not topaz, not turquoise. A gemstone that shares the same mineral family as emerald itself. Aquamarine. Most people know it only because of its beautiful ocean blue color. Few realize they're looking at the blue variety of beryl, one of the most important gemstone minerals ever discovered. Its color isn't paint. It isn't a surface coating. It was built into the crystal while it was growing, as tiny amounts of iron became part of its atomic structure millions of years before the first humans ever walked the Earth. Now imagine discovering one lying loose among weathered pegmatite fragments. Should you keep searching downhill, or should you change direction? Experienced collectors almost always turn around, because one loose aquamarine crystal usually tells a much bigger story, somewhere uphill. The pegmatite that released it may still remain hidden beneath the surface. And if one crystal escaped, others may still be waiting inside. The remarkable part. Nature almost always leaves more than one clue. It rarely rewards the first observation. It rewards the person who follows the evidence, and that evidence is only beginning to unfold. But here's where the story becomes even more interesting. Finding a single aquamarine crystal doesn't necessarily mean you've found the treasure. Sometimes, it means you've only found the messenger. Imagine kneeling beside a weathered mountainside after spotting a pale blue crystal among loose gravel. Most beginners become excited and begin searching the ground around their feet. Experienced collectors do something completely different. They begin looking uphill, not because they expect another crystal lying on the surface, Because gravity always tells the truth. Loose crystal didn't grow where you found it. It traveled. Perhaps only a few feet, perhaps 100 yards. But somewhere above you, the mountain quietly remembers where it came from. That is why professional collectors rarely search randomly once they discover their first crystal. They reverse the journey. They follow the mountain backward. Every larger pegmatite fragment, every fresh block of quartz, every oversized feldspar crystal, every broken exposure becomes another clue leading toward the original crystal pocket. And sometimes that journey ends where nature has been hiding treasures for millions of years. Now another discovery begins. Notice the pegmatite itself. Some sections appear solid and lifeless. Others suddenly contain open spaces, small cavities lined with perfectly formed crystals. These cavities are known as myorelitic pockets. They formed during the final moments of pegmatite crystallization. As the last volatile, rich fluids became trapped inside shrinking spaces, pressure slowly decreased. Instead of filling completely with solid minerals, tiny chambers remained open. Inside those chambers, crystals grew freely into empty space. Unlike ordinary minerals crowded together inside solid rock, these crystals developed complete faces, sharp edges, and remarkable transparency. Some of the world's finest aquamarines have emerged from cavities no larger than a backpack. Now comes another professional technique. Don't immediately strike every pegmatite with a hammer. Walk around it first. Fresh collapses, small natural openings, weathered fractures, sometimes reveal cavities without damaging the outcrop. Nature often exposes the first clue long before human tools become necessary. Patience frequently protects discoveries that haste destroys. But perhaps aquamarine isn't the only surprise these pegmatites keep. Imagine discovering smoky quartz beside aquamarine, then feldspar, then black tourmaline. At first, they seem unrelated. In reality, they are geological companions. Certain minerals enjoy forming together because they were born from the same chemical environment. When experienced collectors discover tourmaline crossing pegmatite beside smoky quartz, they don't simply admire the minerals. They become curious, because the chemistry that produced one rare crystal often produced others nearby. One discovery quietly predicts the next. Now another mystery. Why do some aquamarines remain pale while others display an intense ocean blue color? The answer isn't size, it isn't age, and it certainly isn't polishing. It begins at the atomic scale. Tiny amounts of iron entered the crystal while it was growing. Not enough to weaken it, just enough to change the way it absorbs light. The deeper and more balanced those trace elements became during crystal growth, the richer the blue color eventually appeared. That tiny chemical difference can transform an ordinary crystal into one sought by collectors around the world. Now, another practical technique. When examining aquamarine in natural daylight, rotate it slowly. High-quality crystals often maintain their color from several viewing angles. Poor quality material may appear washed out the moment the light changes. The mountain quietly performed this quality test long before the gemstone ever reached a jeweler. Now another discovery. Pegmatites eventually disappear. Rain continues falling. Frost continues expanding. Entire outcrops slowly collapse. Crystal pockets break apart. Loose gemstones begin entering small mountain streams. At first they move easily. Then something remarkable happens. Unlike ordinary rock fragments, gemstones are surprisingly durable. Many survive transport with their crystal form still recognizable. Streams sort them exactly as they sort gold. Heavier material settles where water slows. Natural cracks capture them. Coarse gravel protects them. And suddenly, the story begins sounding familiar, because although gemstones and gold formed differently, nature often concentrates them using exactly the same forces. Gravity becomes the collector. Water becomes the sorter. Time becomes the patient craftsman. Now another reward. If you discover abundant pegmatite float entering a mountain drainage, don't ignore the first inside bend below it. Inspect gravel resting behind stable boulders. Search exposed bedrock pockets. While not every stream carries gemstones, those that drain productive pegmatites occasionally preserve remarkable surprises long after the original crystal pocket has vanished. And perhaps that's the greatest lesson these blue treasures teach us. The mountain never reveals everything at once. It leaves clues. One crystal, one fragment, one cavity, one weathered outcrop, one quiet stream. Each discovery asks the same question. Will you stop here, or will you keep following the evidence? Because every remarkable gemstone discovery in history began exactly the same way. Someone noticed one clue that everyone else ignored. Then they asked one more question, walked one more ridge, climbed one more slope, followed one more fragment, and eventually the mountain answered. Perhaps that is why nature's greatest treasures rarely belong to the strongest explorer or the one carrying the most expensive equipment. They belong to the person willing to slow down long enough to let the landscape speak. Because every pegmatite, as every crystal pocket, every loose aquamarine, every weathered mountainside, is quietly preserving another page of a story that began hundreds of millions of years ago. A story written not in ink, but in crystal. And the remarkable part is this. Somewhere, on an ordinary mountain that thousands of people may hike this very year, another untouched crystal pocket may still be waiting in complete silence. Not because it is impossible to find, but because almost everyone is looking for the wrong clue. And perhaps the next extraordinary blue crystal has already begun its journey toward the surface, waiting for the one person who has finally learned how to read the mountain before the mountain reveals its greatest secret.